Okay, class, right now we are going to talk about graphs of functions. In the previous videos, we talked about the definition of functions and we saw some examples of functions. Now, it is a correspondence from the first set, which is called the domain, to the second set called the range, such that each element in the domain corresponds to exactly one element in the range. And we also said that it is a special relationship where each input has one single output. Okay, now functions are usually given in terms of equations rather than as sets of ordered pairs. It was mentioned in our previous videos as well. And now we're gonna learn that the graph of, well, I think we know it already. The graph of a function is the graph of its ordered pair. So every single point or every single part of the graph of a function is an ordered pair or is a point. It's infinitely many points. Okay, so let's take a look at this website right here. Okay, so common functions are number one, linear function. We know that when we have y is equal to mx plus b, or anything where the highest exponent is of the variable x is 1, it's gonna be a line. And then here we have the f of x is equal to x squared, so anything with the to the second power is gonna be a parabola, either opening up or opening down. And then we also have a cube function, which is, the highest exponent is to the third power, like f of x is equal to x cubed. So this is how it looks like. And then a square root function where you have a square root of something. So square root of x is actually looks like this. We're not gonna go deep into all of these, but I just want to show you guys how how functions differ from each other. Okay, and then we got the f of x is equal to absolute value of x. So this is your absolute value function graph. And then we got the reciprocal, meaning, the other name for it is the rational function. And then we got the logarithmic function, the log or the ln, which we'll learn towards the end of the semester. And then we got the exponential function like e to the x power, or anything where the x is actually in the exponent. And then we'll see this later in the next following videos, floor and ceiling functions. Okay, or we call it the other name for it is the step function. And then we have the sine function, which is the same as similar to cosine function. And then this is the tangent function. And so here are the samples or examples of different functions. Now, like I said, we are going to, or we are not going to dig deeper into all of these today, but we just want to analyze, at least we have an idea of how they look like. Okay, so now that we know all the types of functions, let's go ahead and talk about the vertical line test. Why is it working? How do we know, using a vertical line test, how do we know if a graph is a graph of a function or it's not a graph of a function? Okay, let's define a vertical line test. If any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. So in this case, I want to make it bigger. Let's see. Okay, I think this is it. Okay, let me see if I can. Okay, so here is a graph that looks like S, and we see that if we draw a line somewhere, like for example, if I draw a line from here to here, okay, hold on. Okay, if I draw a line from in the center, draw that red line, I will hit, okay, so this is my vertical line, which is what we use for vertical line test. So if I draw a line from here to here, I will hit the graph in 3 different points. Like this is the first point, and this is the second point, and this is the third point. And if we name those points, this one is the 0, 1, this one is the 0, 0, and this one is the 0, -1. Okay, now what is a vertical line test again? We said that it is, okay, if any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. So because the line, that vertical line intersected the graph at 3 separate points, meaning more than one, that fails to be a graph of a function. Now, why is it working? Do you guys remember what we said earlier, where if you have a graph, or if we are given something like, for example, you know, okay, let's say for example we're given with this type of set, and that set contains ordered pairs. In this example, the ordered pairs are 0, 1, 0, 0, and 0, -1. Okay, so remember that to test a function, we looked at their first components. And if the first components appear more than once, then that is not a function. So that is why the vertical line test is working, because of this idea that when you draw a vertical line and it intersected the graph at 3 points, and then you write those 3 points, that means the x component, or one of the elements in x, corresponds to more than once. And remember, by definition, function is, well, a relation is a function if every single element in the set, or in the first set, corresponds to only one element on the second set. So this one is not a function because of it fails the vertical line test. And we'll have some more examples in the next video.